us worry about warming when it's just a natural cycle? Climate's always changed, and today's no different, right? If we want to understand why the Earth is warming, it just makes sense to start by taking a closer look at all the natural factors that have caused climate to change in the past. Are they to blame for the current warming? Or do these natural suspects have an alibi this time? Let's start with the sun. We get nearly all our energy from our nearest star, and we know that the sun's energy tends to fluctuate a bit over time because the sun is actually a variable star. When its energy goes up, the Earth gets a bit warmer. When the sun's energy goes down, the Earth gets a bit cooler. What do we see then when we track how the sun's energy has changed over time? Observations show a repeating 11-year cycle that's correlated with sunspots and solar activity. But observations also show a small long-term increase in the sun's energy through the last century. That is, until we hit the 1970s. Since then, the sun's energy has been going down, not up. So over the first part of the 1900s, increasing energy from the sun did contribute to some of the warming of the planet, although not much. But over the last 40 years or more, the opposite has been happening. If the Earth's temperature were controlled primarily by changes in the sun's energy, we would have been cooling, not warming. So the sun can't be causing us to warm now, it has a perfect alibi. What about volcanoes? Volcanoes can affect climate in two ways. First of all, when they erupt, they can spew enormous amounts of soot and dust and ash into the atmosphere. If the volcano is powerful enough, that dust and ash can reach all the way up into the stratosphere, where the particles can circle the globe for months and even years. But volcanic ash and dust doesn't warm the Earth. Instead, it acts like a giant umbrella, reflecting the sun's energy back to space, making the Earth cooler. So clearly volcanic eruptions can't be responsible for the warming. What's the second way that volcanoes can affect climate? Well, in geologically active areas like Sicily or Yellowstone National Park, powerful heat-trapping gases like carbon dioxide and methane can seep out from deep inside the Earth's crust. This can occur during volcanic eruptions, but the majority of it actually happens through what they call mud volcanoes or mud domes. We know that these gases are an important part of the Earth's natural blanket that keeps us nearly 60 degrees Fahrenheit or over 30 degrees Celsius warmer than we would be otherwise. So are the heat-trapping gases that are seeping out of the ground in these areas responsible for our current warming? Well, no. Turns out regular volcanoes, little mud domes, and other geologic activity produce around 1% of the carbon dioxide and less than 15% of the methane that we humans produce every year. So while it's true that long-term geologic activity can warm the planet, its contribution over the past 100 years is pretty much minimal compared to how much of those same gases are being produced by humans. So if it can't be the sun, and it's not volcanoes, what about natural cycles? Could they be causing our current warming? Natural cycles like El Niño, and other lesser-known cycles like the Atlantic multi-decadal oscillation, are all part of the variability that's built into the climate system. Because these cycles are internal to the climate system, they can't spontaneously generate heat. That would violate the fundamental physical law of conservation of energy. Rather, these cycles affect the Earth's temperature by redistributing heat around the world, usually by altering the balance of heat stored in the atmosphere versus the ocean. During a La Niña episode, for example, more heat is transferred from the atmosphere into the ocean, so global average temperature tends to dip a little below average. In contrast, during an El Niño year, more heat is relocated from the ocean into the atmosphere, so global temperature tends to tick up. And El Niño years like 2016 tend to be a little warmer than average. If natural cycles have been causing the atmosphere to warm, they could only be doing this by moving heat from the ocean into the atmosphere. Over the last century then, if the heat content of the atmosphere has increased due to natural cycles, then the heat content of the ocean should have decreased to balance out the total heat in the system. So is this happening? No, it isn't. The heat content of both the ocean and the atmosphere is going up. Not only that, but the increase in the ocean heat content is 20 times greater than the increase in the atmosphere and the land and the ice all put together. If the entire climate system is warming, natural cycles inside the system can't be causing it to warm, because all they do is move heat around. So the warming must be coming from somewhere else. And that leads us to our last natural suspect, orbital cycles. Over time, the Earth's orbit around the Sun becomes more circular and then more elliptical. The Earth's axis of rotation also precesses, just like a top when you spin it. These slow, periodic, and most importantly, predictable changes affect how sunlight falls on the Earth, which in turn affects the Earth's temperature. We've known for almost 100 years that these orbital cycles are responsible for the ice ages and the warm periods in between, like the one we're in right now. So it just makes sense to ask, are we still coming out of the last ice age? Well, no. If we look at the Earth's history, we see that warming after the last ice age peaked about 6,000 to 8,000 years ago. Since then, the Earth's temperature has been very gradually, slowly decreasing on a long slide into the next ice age. We can even calculate where we are in these orbital cycles, and when we do, it explains what we see in the observations. The next thing on our geologic calendar, sometime in the next few thousand years, was another ice age. Was, that is, until that long, slow cooling trend stopped and then abruptly reversed just about 200 years ago. The sun, volcanoes, and natural cycles, they all have an alibi. Now it's time to look for a new factor that might be causing the planet to warm. And it turns out that scientists have known about such a factor for over 150 years. The heat-trapping gases we produce whenever we burn coal or gas or oil, as well as from deforestation, land use change, and agriculture, these gases are wrapping an extra blanket around our planet. This blanket is trapping heat inside the climate system that would otherwise escape to space. That's why we're warming. For the first time in the history of our planet, it's us.